Select the major product of the following reaction. So if we take a look, we are starting with an alcohol, and specifically this is a secondary alcohol. So we can determine that by finding our alcohol carbon, and then we classify this by how many bonds to carbon it has. So we see 2 bonds to other carbon atoms. That's why this is a secondary alcohol. And so what we're reacting this with is SOCl2, which is thionyl chloride, and it has this general structure, and pyridine, and this is what pyridine looks like. And so pyridine we're going to see used quite often in this alcohol chapter, and it is a non-nucleophilic base. So what that means is it can act as a base in terms of it can remove an acidic proton, but since it's not nucleophilic, it won't compete in a substitution reaction. All right, so what's going to take place first is your alcohol has lone pairs of electrons, and this can act as a nucleophile, and it is going to attack the sulfur of this thionyl chloride. So it is going to attack that sulfur and kick off the chloride. And so notice that this pink carbon here was not involved, so because we're forming a bond between the oxygen and the sulfur. So this wedge bond should still be wedged at this stage of the mechanism because that carbon has not reacted in any way. So now we have added to our sulfur this group. And so we're going to take, notice we have a positive charge. This is where the role of the pyridine comes in. This can act as a base and remove that acidic proton. And so then what we have is a structure where we have a really excellent leaving group right here. And so that chloride ion that we liberated in the first step is going to do an SN2 attack and kick off that really good leaving group. So it's going to attack this carbon. So this is SN2. So we know from previous chapters that this is going to invert this chirality. All right, and so this is breaking this down into SO2 gas and chloride. So that's what's making this such an exceptional leaving group. Okay, so we've inverted the chirality. We get SO2, which is a gas, and we form some more chloride ion. But in terms of the major organic product, we're looking for this one here. Okay, so this reaction with thionyl chloride and pyridine, it's going to take a primary or a secondary alcohol, and it'll convert it to the alkyl chloride. If it happens to be a secondary alcohol with chirality like this one, you will see the inversion that results from that SN2 attack.